Humanity's development of new technology has been advancing at an ever-increasing rate over recent decades. If you were to look at how much the world has changed technologically in the 10 years between 1889 and 1899, for example, and then compare that to the amount of change the world saw between 1989 and 1999, the difference would be drastic. In just those 10 years, the world almost completely transitioned to a new digital age. Computers were made affordable and suddenly became a staple in most families' homes. The internet came into existence and gave all of those people with new computers a way to interact and share information with each other across the world. Telephones were made portable, and people were able to call anyone from anywhere at any time. Then, in the next decade, computer power and access to the internet was combined with the mobility and size of a cell phone. Even the first models of these new smartphones, which are now considered almost hilariously outdated despite being released just 10 years ago, have tens of thousands of times more processing power than the room-sized supercomputers NASA used to land men on the moon. Considering that the moon landing was over 50 years ago, and that the technology used to accomplish this feat is vastly outclassed by what the average person now carries around in their pocket, many have wondered why NASA still hasn't gone back to the moon, or gone beyond it, to Mars. Many billionaire public figures have expressed interest in creating their own privately owned space programs that would carry the first people to Mars. Most notably, Elon Musk, the CEO of Tesla Vehicles, who actually has his own space program named SpaceX, which builds and sends rockets and satellites to space on a semi-frequent basis, and who have promised that they will land the first humans on Mars. Musk grabbed even more attention when he announced that his plan to terraform Mars into a habitable planet involved launching a constant barrage of nuclear warheads at Mars's polar ice caps in order to melt them and release the water trapped inside.
You sincerely think that we should go to Mars?
Yeah.
Why do we want to go to Mars? It's uninhabitable.
It's very inhospitable, that's true. It is a fixer-upper of a planet. But eventually you can transform Mars into an Earth-like planet.
How would you do that?
You'd warm it up. It's the fast way and the slow way.
Okay. Give me the fast way.
The fast way is drop thermonuclear weapons over the poles.
You're a supervillain.
But what is terraforming, and why does it involve nukes? Terraforming is a word used to describe the process of turning an uninhabitable planet into one that can support life and human civilization. Elon Musk's idea for terraformation was to launch a constant barrage of nuclear warheads at Mars's polar ice caps and have each nuke detonate just as the one that came before it finishes exploding. This would create a constant stream of nuclear explosions that would form a sustained fireball over the ice caps and melt them, releasing all the drinkable water trapped inside. This water would then be used to grow crops, farm animals, and plant trees which would supply the Martian atmosphere with oxygen. If you thought that plan was crazy, you'd be right. Musk's plan just won't work, but not for the reason you might be expecting. If you thought that the nukes would destroy Mars or cover it in too much radiation, you'd be wrong. You're giving humans far too much credit. We humans and our nuclear bombs don't have nearly enough power to destroy a planet. It was calculated that in order to even make a noticeable amount of ice melt, 1,500 nuclear warheads would have to be detonated above each pole per day. A constant stream of 3,000 nukes per day isn't likely to happen, considering that the total amount of active warheads in the entire world is 3,750. There are other, more sane ideas for Martian terraformation, but what's the point in doing it? For many, Mars represents humanity's first steps outside of their home planet and the beginning of a bright future as a spacefaring species. For them, terraforming Mars and establishing a permanent human presence on the planet signifies mankind's first baby steps out into exploring the universe. A terraformed Mars could be made into farmland in order to grow food for Earth. It could also be used as extra living space for when Earth becomes overpopulated, and Mars could also serve as a base of operations or launching pad for future space exploration. Mars is also the only option for the first planet to terraform because it is the only other planet in the solar system that a human in a spacesuit could walk on and not die instantly from extreme pressure, cold, or heat. But just how realistic is terraforming Mars? The main issue preventing a human from living normally on Mars is the relative lack of atmosphere. Mars's atmosphere has a density and air pressure of less than 1% of Earth's at the surface. If you wanted to find the same atmospheric density on Earth, you would have to fly 22 miles in the sky. Not only does this mean that there is little air to breathe, but this is also the reason why no water is to be found on the surface of Mars. The boiling point of a liquid drops when air pressure drops, and on Mars the air pressure is so low that water can boil and evaporate at below freezing temperatures. Proposed Martian terraforming plans all address this issue by, ironically, figuring out a way to flood Mars's atmosphere with carbon dioxide. Early propositions involved releasing carbon contained in Martian soil and rocks into the atmosphere, but a recent study showed that there isn't enough carbon present in Mars's crust to form an atmosphere. So other plans involving mass release of CO2 by human processes, such as burning fossil fuels on Mars, would supply enough carbon dioxide to build an atmosphere. From that point, the ice caps would melt, trees and crops would be planted to release oxygen into the atmosphere, and the planet would be ready to live on. Although this plan is much more realistic, the amount of time it would take for machines to make an atmosphere and then for trees to fill that atmosphere with oxygen borders on thousands if not millions of years. Throughout the entire time frame, people, food, and fuel would need to be constantly sent to Mars to operate machines and tend to crops, all while living entirely within airtight sealed buildings. So this plan too also turns out to be impossible. Sadly, no matter what plan anyone comes up with, right now it is currently impossible to terraform Mars. The most important issue of terraforming Mars is its lack of a magnetic field. It isn't entirely understood how it works, but Earth possesses a large electromagnetic field called the magnetosphere, which is believed to be formed by the rotation of iron within Earth's core. This magnetosphere plays a crucial role for life on Earth. The sun constantly spews out harmful radiation called the solar wind. If the solar wind were to hit Earth, all living beings would be killed by massive doses of radiation, the atmosphere would be ripped apart and thrown into space, and all water would evaporate away, preventing any life from reappearing in the future. Luckily, Earth's magnetic field blocks all of the solar wind and prevents it from harming Earth. Without the magnetosphere, life on Earth would not be possible. Mars's complete lack of a magnetic field prevents any sort of terraforming project from ever being successful. Without a magnetic field, any attempts to create an atmosphere on Mars would be swept away into space by the solar wind, any water released would quickly evaporate, and all exposed life would soon die. So in conclusion, humanity does not actually have the ability to terraform Mars, and likely won't for a long time. However, travel to Mars is very possible, and so is building airtight buildings to serve as living spaces for long-term colonists. Mars may not be inhabitable in the near future, but mankind will soon see the first person on Mars.